Awesome. So today we're going to be talking about SIF-Syn, which is short for Synteny, which is basically you're comparing genomes and seeing if the gene position within the genome is conserved across different genomes, and if that makes sense biologically. So when you go to put this in your annotation, the basic syntax is going to be like this: SIF-Syn, and then you're going to have the function, and then you're going to have the upstream gene is so-and-so, and the downstream gene is whatever it is. Just like in phage, and then they'll use whatever phage you compared it to. So that's going to be your basic, with this example, that's your basic syntax. It's a little more flexible than others. It's often sentence structure. If you need to put some more detail in it, you can. So if we go back, what you're going to do is you're going to sign in to Phamerator first. Then you're going to go to Genome Maps. So for us, our phage we're using in this example is Sorpresa, which is an A1 phage. So we're going to go to the A1, you're going to click there, and then you can see we've selected several other phages here. Make sure your phage is selected, or in the case that your phage is not yet in Phamerator, select the phage that is most similar to yours, and you'll use that as a point of reference. Then you're going to go up to the top and click View Map. And that'll bring you here where it gives you graphical representation of the genomes. So you're going to go and find your phage. So here we see Sorpresa is right here, and say you're working on annotating gene number 4. So you're going to look and you're going to see graphically, you can kind of see for these are kind of the same, these look kind of the same, these look kind of the same. And also the numbers here are the same, which can be helpful at times. So you can be reasonably confident that these are referring to the same gene, even though this one has some other genes before, but these are your matches right here that you're going to be looking at. So if you look here, you're going to want to see what the function is. This doesn't tell you the function on your phage or this phage. So if you scroll up further, often you'll be able to find one to tell you this is putative structural protein, which isn't a very strong call, but minor tail protein is a little stronger. You see it's there as well. So there's one up above. So minor tail protein seems to be what Phamerator is calling this. So in your function, in that other screen that we have here, you put minor tail protein. If we go back, scroll back down to our phage, here we see that this is, we don't have the call yet. We scroll up, we'll see if any others do. That just says putative structural protein, not a very strong call again. So either putative structural protein or hypothetical. Occasionally you can click on these and they'll give you more information, but not always on the function. So yeah, you put downstream, hypothetical, and upstream, kind of the same situation here. This does not seem to have a call on it, but if you scroll down, you can see that that's similar to our phage. Scroll all the way to the bottom. It looks like the same guy there, same with this one. And that looks like a hypothetical upstream as well. So in your annotation, you put upstream, hypothetical. Something to be aware of is these are all forward genes. But if we scroll to the side here, you're going to come to a point where your genomes are reverse genes. Here we are. So this is how Phamerator displays it. It goes from here to here. That's where it switches to reverse. These are not part of Sorpresa. These are part of Scow. So don't get confused there. The order of upstream and downstream, because it's a reverse gene, is going to swap. And so, because it's a reverse gene, and that stays consistent here, you're going to see, for example, here we're talking about gene 43, now this would be downstream. 42 would be downstream of 43, and 44 would be upstream of 43. So keep that in mind. That's not necessarily something to do with Phamerator, but because of the nature of reverse genes, that's how the upstream and downstream work. So another thing you might run into, if we scroll over to the side more and up to the top, you're going to occasionally come across something like this. Let's see. Scroll down just a little bit, if you would, thanks. So yeah, this is a good example. Perfect. Right here, you have the say your genome. This is your genome right here. You're working on gene 73. You see that is comparative to gene 77 in this guy. You see it's the same. In the downstream direction, you have the same gene. In this case, it looks like it's an immunity repressor. So that's all fine and good. But upstream, you have this hypothetical, but it's different from this hypothetical. And you're going to run into that throughout your annotations. And if you can find a genome that is the same hypothetical, that is probably best. If you can't, then you're going to want to notate that. You're going to want to say, function, hypothetical, upstream, immunity repressor, just like in scowl, downstream, hypothetical, but different hypothetical than in scowl 1. And then if you want to say, we could not find any phages with the exact same orientation, that's up to you, but you will want to notate that. And then just a few bonus tips on how to use the program to make things just a little bit easier. So a neat feature is you're able to click and drag the title of the phage. You're able to bring it up, switch the order. That can make it easier if you wanted to compare your phage to the different phages rather than trying to remember as you scroll up. You can also click on a gene of interest, say this Cas4 exonuclease, for example. If you click, maybe it's a little bit to the side of the number on the color parts. There we go. It's going to give you information. This is the DNA sequence. You can get the protein sequence. Sometimes the function will be up here, not always. And it can give you like what clusters. It can show you, okay, phages with this particular gene are in these clusters and subclusters. And that information from time to time can be helpful as well, if you should need it. So that is how you do SIF-Synteny. It's a lot less structured than some of the others. That is okay. Just use this as a tool to compare it. And if something seems off, then use some of your other tools to be like, okay, is this actually right? This feels a little wrong when I'm comparing it, but why is this actually correct? And this will help you to do that. So good luck on your annotations.